All right, this video is going to go through the last set of questions on Power Standard or Indicator 7.2. We're going to start with question number 23 here, which is on graphing. You need to find all the little bits, parts, and pieces. So I always start with finding the axis of symmetry first. That is going to be x is equal to the opposite of b over 2a. The opposite of b here is going to be 2 over 2a is 1. So our axis of symmetry is x is equal to 1. Now, once you find that, that actually gives you the x value of the vertex, which is nice. How do you find the other value of the vertex, the y value? Well, you're going to go to the original equation, and wherever you have an x, we're going to replace it with, in this case, 1. So 2 times 1 and then minus 3. So 1 minus 2 minus 3, what is that? 1 minus 5, so negative 4. Yeah, that looks good. Let's do some zeros. To find the zeros, we're going to make the function equal to 0, and I'm going to factor that. So factor, split up the 3, make the 3 negative. Whoops. Make that a positive. So we're going to get zeros of positive 3, 0. That's the ordered pair. And then negative 1, 0. And then for the y-intercept, make x equal to 0. So 0 squared minus 2 times 0 minus 3. That is going to be the order pair 0, negative 3. The domain for any quadratic equation is negative infinity to infinity. And the range I'm going to hold off on until I actually draw the picture. Okay, so I have all of these pieces of information here. I've got my vertex, I've got my zeros, I've got my y-intercept. Let's go ahead and put it on the graph. So let's see, I've got 1, negative 4 as my 1, 2, 3, negative 4. I believe I don't remember my zeros. 3 and negative 1, so those are my x-intercepts. So 3 and then negative 1. And my y-intercept was negative 3, 0, negative 3. Oops, stop moving this around that much. All right, so 0, negative 3. And axis of symmetry goes right down the center here. Now, the one nice thing about the axis of symmetry is if you want to, the point here is mirrored on the other side of the axis of symmetry. So there's a point sitting right here if it helps you draw the curve a little bit better. And once you got that in, draw the curve in place. There you go. You have just drawn a quadratic and identified all of its little bits, parts, and pieces. All right, question number 24, write the equation line that passes through those 2 points. So we got to do a little slope here. So m is equal to, I'm going to take my y minus my y over my x minus my x. So 6 minus 8 is going to be negative 2. 4 minus a negative 2 is going to be 4 plus 2 is 6. That is negative 1/3. And there's a couple of different ways to write the equation of a line. I'm actually going to use point slope form. And that's going to be y minus, you pick either point, by the way, doesn't matter. I'm going to go with the 4, 6 point. So y minus 6 is equal to negative 1/3 x minus 4. And that's honestly the equation of a line, right? You are welcome to leave it that way. If you don't want to leave it that way, that's fine. You can multiply this out. So y minus 6 is equal to negative 1/3. There we go, right? The 3 in place. Plus 4/3, and I'm going to add 6 to both sides. So y is equal to negative 1/3 x plus. All right, so let's do over to the side here, 4/3 plus 6. That would be 4/3 plus, I need a 3 here. So times that 18/3. Yeah, that would be right. So 4/3 plus 18/3 is going to be 22/3, and that's the other, that would be your point slope-intercept form. Okay, so here's the thing. I don't care which of these answers you give me. You don't have to give me both unless I specify in the directions which equation to write. If it says put it in point slope form or slope-intercept form, great. Other than that, I'm completely happy with point slope form. All right, question number 25. This is one reason why you would want to use slope-intercept form. So I'm going to go ahead and subtract 2x and subtract 12 here. All right, get this as negative 3y equals. So that's gone and that's gone. So negative 2x minus 12. Look at all the negative signs. That's a lot of negatives. All right, so y is equal to 2/3, right? Because a negative divided by a negative is a positive. Negative 12 divided by 3 is positive 4. So we're going to use positive 4 as my y-intercept. So starting here at positive 4. And then that slope is going to tell me to go up 2 to the right 3. Then up 2 to the right 3. And so I'm going to do that a few times. Up 2, 1, 2, 3. Up 2, 1, 2, 3. And then instead of going up and to the right, I can go down 2 and then left 3 to find more points on my line. So down 2, left 3, down 2. I've ran out of graph there. And the reason I do this is that when I go to freehand the line in, that's awful. That'll straighten out. There it goes. When I do try and freehand the line on paper pencil, the more points I have, the more likely I am to get the line in about the right place. All right, question number 25, done. Okay, use the unit circle. So I'm going to need to bounce out of this note sheet into one of my prior note sheets that actually has a unit circle on it. So I want the cosine of 180. So let's go to notes 100. Okay, so 180 is right here. This is the ordered pair, -1, 0. And every ordered pair is cosine sine. So -1 is the cosine value. All right, that one. Yep, that one. All right. So that's going to be -1 here. That's the answer. That's it. We're going to do sine of 330. So let me bounce back to the unit circle here. Bouncing back and forth. All right, so 330 degrees. This is the ordered pair. The sine value is the y value, so -1/2. All right. Oops, right with a pen. So -1/2. Now, tangent's going to be the goofy one, right? Tangent of 210. So let me go grab that information from our unit circle. Where we're at. 210 degrees is right here. So -√3/2 and then -1/2. Now, I'll figure that out in just a second. Okay. So let me write that down. The ordered pair was -√3/2, comma -1/2. Now, tangent, by definition, one of its many definitions, is sine divided by cosine. So we're going to create a fraction here, -1/2 over -√3/2. I do not like the fact that this is a complex fraction, and so let's undo it by multiplying by the reciprocal of the denominator. Okay, so in the denominator, the positive, right, negative times negative is a positive. And then we've got √3 and √3 cancel, 2 and 2 cancel, all that denominator stuff is gone. In the numerator, we've got a negative times a negative, so that's a positive. The 2 and the 2 cancel, and what's left is 1 over √3. Don't like that. Let's go ahead and rationalize out that denominator. So this is going to be √3/3. All right, so that's all the little bits, parts, and pieces using the unit circle. Let's see, convert to radians. Well, the conversion is pi is equal to 180 degrees. If I give you degrees, I want pi in the numerator, degrees in the denominator. All right, so fractionally this becomes 120 pi over 180. Let's go ahead and grab a calculator. All right, let me zoom in so I can leave this up, and I'm going to bring this calculator over just a little bit. There we go. All right, so what goes in the calculator is the 120 over 180. So 120 divided by 180, I get that mess of a decimal, don't like it. I'm going to hit math and then enter. So the math is going to take the last answer, right, and turn it into a fraction. And then enter again, I actually get my fraction. This is, whoops, pen, 2 pi over 3. Okay. If I do part B, same exact thing. We are multiplying by pi over 180 degrees. The degrees are gone, so you're left with 270 pi over 180. So what goes in the calculator? 270 divided by 180. Ugh, not a huge fan of the decimal. Math, enter. Ooh, look. All right, I like that better. So 3 pi over 2. Now, the questions directly below this I'm giving you radians this time, and I want you to convert to degrees. So we're still using the same exact conversion. We're just flipping it to cancel out the radians this time as opposed to the degrees. So pi is gone, and I'm left with 180 over 2. I don't need a calculator for that. That's 90 degrees. All right. And then 11 pi over 6, same situation. We want the degrees in the numerator, pi in the denominator. So in the calculator, I'm going to do 11 over 6 times 180. So 11 over 6 times 180. All right, that is, whoops, I keep forgetting to go back to a pen here. So 330 degrees. Let's get rid of the calculator for right now. If I need it back, I'll pop it back. Okay, so we're done with converting. Yeah, I'm going to need the calculator back in a little bit. Question number 28 says to find the missing parts in the right triangle. So I'm going to go ahead and label, let's see, this is X for angle, and we'll go ahead and put a Z here for the side. All right, I'm going to actually find, what do I want to do? Let's put X here, Y here, and then Z here so I can keep track of my answers. I'm going to set up 2 little miniature equations for trig to find X and Y. And the basic idea here is if I set up for Y, this is the adjacent side, this is the hypotenuse, so we're going to do cosine. Whoops, I don't know what just happened. Let's go ahead and expand that out. Okay, so let's do cosine of Y is equal to the adjacent side over the hypotenuse. So that means I need to do the inverse cosine of 18 over 20. Let's go ahead and grab that calculator back. Shrink it just a little bit and expand this one. Okay, so inverse cosine, I'm going to do second cosine. That gets a little inverse notation there. 18 over 20. Am I in the right mode? I am in the right mode. All right. That's important stuff to know. All right, so we're going to have Y is equal to 25.84. This is degrees because it's an angle. So there's what Y is. Let's do a similar situation for X, but we got to be careful because for angle X, that's the opposite side. Now, that's still the hypotenuse. But let's see, opposite and hypotenuse are going to be, whoops, let's write the right thing here. That's going to be sine of X equals 18 over 20. So for X, we're going to do the inverse sine of 18 over 20. So second sine, that's the inverse. Fractions 18 over 20. All right, so that's going to be 64.16 if I round it off. So 64.16 degrees. Now you've done all this lovely work in trigonometry. And for Z, I'm not going to do trigonometry. I'm going to recognize this as a right triangle, which it is, right triangle. And I know 2 of the sides. I'm going to just do Pythagorean theorem here. So Pythagorean theorem says 18 squared plus Z squared is equal to 20 squared. 18 squared is 324. Plus Z squared equals 20 squared is 400. Let me double check that just to make sure. It is, okay. So if I subtract 324 from both sides, Z squared is equal to, I think it's 76. 324, I was right, 76. All right, square root both sides. Write the right letter there. Z is equal to, all right, 76. How can I break that up? Let's divide it out of 2. That's going to be 38. Divided another 2. That's going to be 2 and 19. 19 you're stuck with. That you're just done with. So this is going to be the square root of 2 times 19. So all together now, that's going to be 2 root 19. The pair of 2's, 1 escapes, and then the root 19 stays. All right, last question on the review. Find the length of the arc and the area of the sector. X is equal to 9, which means X is my radius. All right. So let's say I want to find the length of the arc. That means I'm going to start with circumference. That's 2 pi r. So that's times by, what was that, 9? It was 9. And that is going to be a circumference of 18 pi. Now that is going all the way around the circle, but I don't want to go all the way around the circle. For the arc, I am just going 80 out of 360 times the circumference. Now, what goes in the calculator is the fraction 80 over 360. So let me pop the calculator back up. All right, so clear this out. Clear. Okay, we're going to do 80 over 360 and then times by 18. I am not going to put pi in the calculator because that's just going to get into a whole bunch of messy decimals. So 80 over 360 times 18 is exactly 4. So the arc is 4 pi. I don't have units, I don't think, in this problem. No, there's no unit, so I'm just going to let it be 4 pi. All right, so that's the arc length. And then I also want to know the area of the sector. So we're going to do something very similar. I'm going to start with, well, what's the area of the whole circle? So area equals pi r squared. So that's pi times, what was that, 9. So area equals 9 squared is 81 pi. All right, great. That's the whole area of the entire circle. But our sector isn't the whole circle. Our sector, so area of sector, that's going to be 80 over 3. Try again and write a 6. There we go. 80 over 360 times 81 pi. Man, I am having trouble writing. I write too fast. All right, so 80 over 360 times 81. That is equal to exactly 18. So area of the sector is equal to 18 pi. And again, we don't have any units, so I can't figure out if it's feet squared or inches squared or anything like that. All right, that was all of the work. Let's see if I can pinch it all the way down. There we go. There's all the bits, parts, and pieces for indicator 7.2. I'm sure this was a nice long video, but as always, if you have any questions or concerns, please let me know.